Well, here's a use case for public key cryptography. In this example, we have a user who is making a connection to a server, building an SSL VPN tunnel. In the first step, the user is going to connect on TCP port 443, and of course that's the well-known port that's used for HTTPS, which we know uses SSL or TLS. And in this case, the server is going to reply back with his signed identity certificate. That identity certificate contains the server's public key. Now in this case, that server has already gone out, enrolled with the CA server, and gotten an identity certificate. At this point, we need to have the root cert, which is the public key of that CA server, so that we can validate the server's certificate. So the user software is going to verify that signature. We're going to validate it using that server's public key. So again, this is asymmetric encryption that's happening here. At this point, the user is going to create a shared secret key. Now that encryption key is going to be derived with different key exchange mechanisms. Remember, we had a cipher suite that we could select from, and part of it included authentication. So we're going to figure all of that out. The shared secret key is going to be encrypted with that public key of the server. So the server is the only one who can decrypt that message, so we send it. The server then retrieves that encryption key, and then from this point on, we can do bulk encryption, and that's going to use that shared secret key. And now we've switched from the asymmetric encryption, where PKI was being done, to the real-time traffic, where we're using a symmetric encryption algorithm like AES for the real-time packet transfer. Now when we look at our certificates, in this example we're looking at the learningnetwork.cisco.com website, and we can see that it is a website that is accessed via HTTPS. We can see in our browser that the identity was verified, and if we click on certificate information, we can actually look at the details. We can see who this was issued to, we can see who this was issued by, and we can see the validity period. And this is just a very general overview. We could click on the details and get even more details about this certificate. When we do that, we can see things like the public key. We can see that the public key uses the RSA encryption, 2048-bit. We can see that there is a unique serial number. This is the serial number that we would find on the CRL if we were looking to see if it had been revoked. And we can also see that as the cipher suite was negotiated, we can see that SHA-1 was selected as the hash algorithm to digitally sign the certificate. If we look at the certification path tab, we can see the learning network is who was issued this certificate. We can see the hierarchy here of how the certificate was issued from Verizon Akamai Secure Server and from the Baltimore CyberTrust root. And if we take a look at our trusted root certificate authorities, we can see here we have a root certificate. That is either going to be an unsigned public key certificate, or it could be a self-signed certificate that simply identifies the root CA server that we're using in the PKI. And of course, this is part of the PKI scheme. From time to time, we see some warnings in our web browser that relate to SSL or TLS. One of the common messages or warnings that we get is that the host name or the identity is mismatched. And oftentimes this is because the name that's specified in the URL doesn't match what's in the server's identity certificate. In other words, who it was issued to. So it's important to make sure that DNS resolves to the same name that we have issued the certificate to. The validity date range, that's typically going to be related to a certificate expiring, and a signature validation error is going to occur when we're not able to validate the signature, so we can't verify that the public key is authentic. And so if the root certificate of the CA is not available in our certificate store, then we'll say that we can't validate the signature, and the connection is unsecured. Essentially, we'll have a failure of our SSL or TLS session.